Hi everyone, and welcome back to Dev Show. Today we are back with a really interesting topic that you actually asked for it, and that's why that we are covering this topic today. My name is Sherry List, and I am one of your hosts today, together with good colleague of mine, Rasmus Jack. Hi Rasmus, how are you doing today?
Hi, Sherry. I'm awesome. So, keeping healthy and safe and living the work from home life still here in Denmark. And it's a special day today. We have an awesome topic on the agenda, and we have actually had, including this, 30 episodes of Dev Show. So that's a round number we are celebrating, right?
Yes,
Congratulations, everyone in the community.
yes, congratulations.
How
That
are
is
you?
I am very pumped because we have this celebration today, at the 30th episode. And also, at the moment, I am organizing the climate hackathon, which is the second day and is going very strong. And this is actually, yeah, many of you might know because I talked about that climate hackathon a lot in this year. So it's a very it's a topic that is very close to my heart, and I am so happy to see we have a lot of teams that they are so dedicated working on these challenges. So as for today, before I pass it over to Rasmus that talk about the topic, I want to also mention that of course we have a Q&A, and our speaker is going to answer your question, and all we want from you is that to type your question in the chat. Doesn't matter if you're watching us from Learn TV, YouTube, Facebook, or Twitch. You can type it down, and then we are going to highlight it for our speaker, and he's going to answer that. And we need you to familiarize yourself with our code of conduct, with Rasmus actually highlighted it here. It's very short and sweet. All we want from you is that to be respectful and mindful of your comment. And we are enforcing our code of conduct if it's needed. It's never been needed, and I hope we never need to do it. Okay, so apart from that, we are also going to later on highlight you a link on how you get your Azure Heroes badge, and also a link to our feedback form. Yes, that it is. We also have it here. So at the end of the show, we are going to talk about this program. So back to you, Rasmus, about the topic.
Yeah, I'm super excited because also, I mean, it's you in the community that asked for this topic, and we have a speaker today that has a lot of experience within this. So it's super exciting. So we're gonna learn today about the SRE, which is Site Reliability Engineering. So I don't want to say more because David, which we are gonna welcome to Dev Show now, he is much more knowledgeable within this area than I am. So we have David with us from Boston. Welcome to Dev Show, David.
Hey there. Hey, Sherry. Hey, Rasmus. Congratulations on 30. That's actually quite a landmark. So
Yeah.
well done. Well done indeed.
Yeah, thank you very much, and thanks for joining us.
Oh, it's my pleasure.
Great.
So David, you are working at Microsoft and you are working as a senior cloud advocate. And so what do you do in your current role? We were just talking about it before that. Then you actually had to think about what do you actually do in your role?
Oh, yeah. Well, sometimes when people ask me that, I say that I pass air over my larynx for a living. But that's not really all. I'm an advocate, which means my job is to go out and to talk to people, to our customers, and to be an advocate, not for Microsoft per se, but I go out and I talk about site reliability engineering and other modern operations practices. But I'm also an advocate for the people that I talk to because I'm in an engineering department, and I take all the feedback that I hear when I talk to people about this topic and others and bring it right back to the mothership where we really are interested in making sure we listen and do the right things around this stuff.
That's great. And you also wrote a book, is that true?
I have written. I'm I have to admit, 2 books.
Oh,
One
that's
has a second edition, so I don't know if that was almost 3 books. One of them is on the topic on site reliability engineering, and strange enough has the same title as today's talk, and I'll explain that later. The other was back in the dark ages where we were shoveling coal into the servers, and that was a book on how to automate system administration using Perl, a language I still like to this day, and I'll admit it, even on live on air right now. So.
And that also just shows how long time you have been in this area, right? It's
Yeah,
like 30 years, you say, right? So you have some
yeah,
experience.
it's over 35 years now. If the gray beard doesn't tell you, then that certainly gives you some idea. Back in the day where we had to write everything by hand and punch cards. No, actually, there was no punch cards involved. But anyway, let's just pretend, okay? It was a long time ago. So yeah.
great.
That's amazing. We really enjoying having you here, David. And I think let's jump into your topic and to SRE. And I just want to emphasize for the audience that please ask your questions. We have the deepest knowledge here. So if you have questions within this area, let's have them in the chat, and we will pass them on to David. So and we are looking at you, David, not in your somebody else, right? You are the deepest.
I'm sorry, I just didn't know who we were referring to. Excellent. Yeah. I'm happy to answer questions. I think it'll be a little easier from a logistics perspective to answer them after I'm done speaking. But I want you to know that I really want you to ask stuff. So this can be a little bit more of a dialogue. First, I'm going to sort of speak at you, and then we'll talk together.
Perfect.
Sounds really good. Thanks, David. We will bring your screen on the broadcast here and jump in the background. So take it away from here.
I will. Thank you so much. Well, so thank you very much for having me here. I feel very honored. It's the 30th. So what I want to do is I want to tell you a story first. And this is a story told to me by one of my colleagues, Nick Stenning. And I'm going to tell it to you a little bit the way he told it to me. I'm also going to be a little nasty, and I'm not going to tell you the entire story right up front. I'll tell you part of the story, and then we'll come back to it later on in this talk. So what you have on your screen is a picture of an aircraft. And this is an aircraft from World War II called the B-17, or the Flying Fortress. And one thing that happened during World War II that not many people know about is that this B-17 was involved in a series of accidents. We don't know all the details of these accidents, and we don't exactly know how many there were. It was wartime. Things were classified. They're still kind of classified, but I'm going to tell you everything that I know about this. So here's but it was really weird, right? So here's what would happen. In each case, what would happen is the following. A B-17 would come into land, would land successfully, and then either on the runway or taxiing back to the hangar, something strange would happen. Something that is not supposed to happen. Something that nobody expected would happen happened. So what would happen is it would come in, it would land, and then on the way to the hangar, or that it would just sort of collapse onto the runway or the tarmac or wherever it was at the time. And this was really weird. The good news I just want to say is that as far as I can tell from the records, nobody ever got hurt. There was nothing here, but it just was puzzling everybody. And so they spent a lot of time trying to figure out what was going on. In each case, the investigators would look for some evidence of mechanical or electrical failure. In each case, they couldn't find any. And what they concluded after a lot of looking was that this was a case of pilot error. And that was the problem. Now, I just want to say that this story might raise some questions in your mind, right? And we're going to come back to it. But for now, let me just give you 2 other additional pieces of information just to understand. First off, the investigators were absolutely correct. No mechanical or electrical failures were happening in this case, none whatsoever. And 2, there might be more to this story, and I'm hoping that it brings up questions in your mind. But you came here to talk about SRE, and believe it or not, we've actually started that discussion. But we're going to come back to this story because I want to get right to this question that I think everybody starts to ask, which is, what's SRE? And so I'm going to give you my best definition. There are a number of definitions out there. This is the one I like, and I'll explain to you why I like it in a moment. Here's the definition I like. Site reliability engineering is an engineering discipline devoted to helping an organization sustainably achieve the appropriate level of reliability in their systems, services, and products. And the reason why I like this particular definition so much is there's at least 3 crucial words in this definition that if you understand them and what they're doing in this definition, you can start to really understand what SRE is. So let's pull them out at a time. If we were all together in the same place, and I look forward to some time when we can do that, I would ask the audience to pull out the words, and it's really interesting to see which ones people pull out. Often they get the same ones I do, and sometimes they get the ones that I don't pull out, and that's really a discussion I love to have. So the first thing I want to pull out of this particular definition that I think is absolutely crucial to start with is the word reliability. This is probably the one you definitely guessed, right? And so the question, the thing to note here is that site reliability engineering, besides having it in the middle of the name, is really laser focused on reliability as a primary thing it's striving towards in the systems that we run. And the reason is this: you can spend as much money as you want hiring the best developers, and we're going to talk about this whole topic from the developer's perspective, by the way. The best salespeople to sell what you're selling, they can add the best features, you can get the right support people, you can write great documentation. But here's the thing. If you're having reliability issues with this, when you go to actually run this, if you put it in front of customers or anybody who's going to go use it and it doesn't work, you can start to lose certain things because of this lack of reliability. The first thing you can easily lose that comes to mind is money, right? Like if you're selling something using what you just built, you would in fact be losing money, you know, and that's not good. The second thing you might be losing is time, because outages are unplanned work. There is nobody that I know of that gets out their calendar and writes down Thursday, database layer will have a problem where the disks fill up. We will spend roughly 2 hours trying to figure out what's going on, and eventually we will bring the system back onto line. Like, that's never in anybody's planner anywhere. It's unplanned work. The other thing that you can lose is reputation, because as people start to think, oh, well, you know, your service is never up, I'm not going to go use it. And we know that customers easily go elsewhere, or even internal customers just lose faith in you. The other thing that also I think is really important to bring out is there's a potential loss of health here. If you're getting woken up every night at 2 a.m. by a page of some sort, if you are finding that you're doing things, and I speak from experience, like spending an entire Father's Day in the data center trying to get things working, or if you don't have time with your family or time for yourself for self-care, you are going to take a serious hit of health. And this is what reliability can do. And then finally, it is possible to have issues with your hiring, because people talk in this industry and they know that that people do not, they hear about your environment and they won't want to work there. And so the basic idea here is you can spend a lot of time on this, but if you're having trouble with reliability, it all goes in the trash. And if you don't actually like this particular animation, I have a lovely one of a toilet that I'd be happy to show you. But let's get back to the definition. I want to get back to the other words. The second word I want to pull out of this definition here that we were just saying before, that I think is absolutely crucial, is the word appropriate. One of the things that SRE brings to the conversation in operations that wasn't necessarily here before was the notion that there's an appropriate level of reliability for your systems, services, and products. Yes, there's definitely systems and services that have to be up 100% of the time, the thing that beats in your chest or the thing that flies in the ear. Yeah, you pretty much want that to be 100% reliable, but most everything else doesn't need to be and shouldn't be sought after as a thing to be 100% reliable 365 days a year, 7 days a week, 24 hours a day, for a number of reasons. One, often you can't make use of that reliability. So let's say that people are trying to contact your system over an ISP and their ISP isn't 100% reliable. Well, it doesn't help there. Two, you don't have any headroom to change things because you're always trying to make sure that you have no downtime at all. So that limits your ability to change things, to innovate. And the other thing is that sometimes it's not even possible. And what I mean by not even possible is if you build a system, which we all do now, that has a bunch of dependencies, maybe like a payment processor or an authentication system or something like that, and they're not 100% reliable, it's really hard for you to be 100% reliable. So what we're seeking in SRE is the appropriate level of reliability. Okay, one last piece out of this thing, and then I promise we'll move on from this definition. The other word that I really want to pull out of this that's really crucial to me is sustainably, something you heard talked about before. It's really important to build an operations practice that you can sustain, a sustainable operations practice, because here's the thing. We know that reliable systems are built by people. And if the people that you employ are burnt out, if they can't bring their best to the job, if they can't do their best work because they're always fighting fires, then you can't build reliable systems. And so it's crucial to pay attention to the people part of the social technical systems that our systems really are. Okay, so let's move on to sort of what's at the basis of this sort of stuff. I mean, how do we think about this? What are some principles and practices? So I'm going to give you some of mine. There are a ton of these. It's like standards. The nice thing about them is there's so many to choose from. But let me just do this sort of layout, and then we'll see if this helps with what you're looking for. So first, a few core principles from my perspective. First is the thing that we talked about already. SRE focuses on reliability. The thing that I have often said is one way I know whether there's a site reliability engineer in the room is if you happen to have an architectural diagram on a whiteboard and they walk into the room and before they sit down, they look over to the whiteboard and they say, oh, you know, you got a single point of failure over there, and what are you going to do about this thing over here? Right? It's a little bit like security folks, right? Who can see things through a specific lens and become very fixated and can help you figure out how to make things better from that perspective. SRE's headspace is production. They're always thinking about how do I make a reliable production environment? And you'll see where that comes into play in just a moment. I'd like to say that SRE manages scale and complexity and a whole bunch of other different things. That's pretty obvious. And in order to do that, it's absolutely crucial that it uses engineering and architecture. And yes, IT has a role to play in it as well. But it's not the sort of thing you can sort of easily just sort of do in your spare time. You have to bring engineering and architecture to bear. And then finally, the last thing, as I mentioned before, is SRE uses technology, but it respects the people aspect of things. And that's crucial to know. So I want to now answer the top question I typically get during a thing. And if we were doing this sort of interactive thing, people at this point would probably raise their hand and say, okay, David, I kind of get this SRE thing that you just said, but what's the difference between that and DevOps? And it turns out to be a really complex question. And it's taken me a while to get an understanding of this. And the best I've been able to do is get 3 different answers to this question and merge them together in my own head to really understand this. And so I'm going to give you my 3 answers, the ones that I have collected that feel more satisfying to me. And maybe one of them or all 3 of them will speak to you and you'll know where to go with this. So answer number 1. And this is good for devs, but this is not always good for all audiences, which is why I'm not as fond of this particular one as some of the others, is class SRE implements interface DevOps. And if you're a programmer, this probably immediately clicks in your head. If you're not a programmer, what this is attempting to say is that SRE could be thought of as a concrete implementation of the DevOps philosophy. An instantiation, if you would, of the DevOps philosophy, because DevOps is intentionally not particularly prescriptive. SRE is pretty darn prescriptive, and as a result, this could be considered an implementation of that overall philosophy. Maybe that speaks to you. The second one comes from a discussion I had because I'm expecting that other people on the listening to me now have had this experience that I did, which is I had this crisis of faith over DevOps. I was like, okay, I thought I understood it, and I have been doing it and dealing with it for as long as it's been around. But what if I were to tell somebody else what is DevOps, and I wanted to tell them what is DevOps in a single word that it distinguishes it from everything else that I could talk about, what would I use? For SRE, it would be reliability, but what would I do for DevOps? And so I had a conversation with Donovan Brown, who used to be my skip boss, and he came up in the course of the conversation. He said something that made it click for me. He said to me that DevOps is about delivery, not just like CI/CD, but like delivery of value. And so I think it's very safe to say that reliability is to SRE as delivery is to DevOps. And that's one way that I like to talk about it. Now, one last way to talk about this comes from my friend Thomas Limicelli, who's written some great books on cloud operations and system administration in general. And he suggests that the difference between SRE and DevOps is one of the direction of attention. And let me explain that in sort of a more concrete way. So here's a super sophisticated diagram here where we have the developer on one side and the production environment on the other. I know that your environment probably is a little more complex than this, but bear with me. And so let's assume that we have a developer, as one does, who's writing code, and the developer takes and brings that code over to production. And so what DevOps is doing is it spends a lot of time thinking about what is a good way for us to deliver the code that is produced by a developer on the developer's machine into production. And it goes through a CI/CD pipeline, and that's that's why there's all this emphasis on pipelines, right? It's this delivery aspect. We don't necessarily in DevOps spend as much time looking at the feedback loop back from production to developer, but we could talk about that some other time. But this is the direction of attention for DevOps. SRE instead starts from production, like we talked about before. I said the headspace is in production, and thinks about what would be necessary to create a reliable production environment. So it's looking backwards from production down to the developer. And so it's trying to figure out, well, what do I need to do to make sure that I have a reliable production environment? And to a certain extent, the tools are often the same. Like, SRE uses CI/CD also for sure, but it's doing it for a different reason. And it's also, and I know DevOps does this as well, it's also recognizing that, like, you can have straw on one end of your pipeline, but it doesn't mean putting it through the right gauntlet or the right pipeline is going to mean that you're going to get gold in production. And that's just a thing that you all know as developers. But it's this difference of the attention direction that I think distinguishes the two of them. And so the same tools are sometimes used and the same things, but they're used for different reasons, and that helps me understand this. Okay, so now that I've convinced you that there's something here to pay attention to, often the next question I get is like, so how do I start with SRE? And when they're asking me this question, often what they're asking me is, how does an organization get started? And we'll talk about how an individual gets started later. But how does an organization get started? So what I like to do is use this map. This is a structure called the Dickerson hierarchy of reliability. So it's meant to be a hierarchy that's like a riff from Maslow's hierarchy of needs. It was created by Mikey Dickerson, who was the SRE who was responsible and became the founding administrator of the United States Digital Services, and was dealing with a big reliability crisis. He came up with this hierarchy. And this is meant to be like any other hierarchy, though my understanding is that Maslow himself never actually drew a pyramid. I had a friend who worked for him. But let's just pretend that we did, where the idea is we have this pyramid, and in order for us to move up the pyramid, we have to make sure every one of the levels every one of the levels is solid. So in order to get to the second level, we have to make sure the first level is solid, and so on and so on. But what is this for reliability? So this is what Mikey posits. Mikey says the first level that you have to pay attention to is monitoring. And I know this is something that doesn't necessarily come into play as much in the dev space, but you hopefully, as you're writing code, as you're working on this, you're thinking about how can other people tell whether the code I'm writing is doing what it's supposed to be doing. When it comes to monitoring, the goal here is like John Cage used to ask, are things getting better or are they getting worse? Right? And without monitoring, you just don't know. Did the changes I made to my code make things better? Well, without monitoring, I don't know. So it's a crucial first layer. And I know that it's crucial, and it doesn't always show up because I have been interviewed for a job which somebody asked me to run a global, like a global multi-time zone SRE group. And I said, well, tell me about your monitoring. They said, well, we do have a monitoring system, and we do have 2 FTEs who maintain it, but nobody really pays attention to it because it's too noisy. And I was like, oh no, this is what I'm going to want to work on first if I came to work for you. And I didn't actually wind up working for them for other reasons, but that was one sign of like, uh-oh. So the next thing that is in the hierarchy is incident response, because there's this observation that no matter what, you're going to have outages. And either your outages are something where you're running around, the English idiom would be hair on fire, like, or it's something that you can effectively triage, bring the right resources to bear to figure out what's going on and to mitigate things effectively as an operational practice, as a process versus doing everything ad hoc. So if your incident response isn't good, you need to pay attention to that. And then comes a really crucial layer in this pyramid that I will be glad to talk more about later. And I have an entire other talk on one because it's something that's really interesting to me. It's how do we learn from our failure? How do we do a post-incident review that allows us to review what happened? So it's not just a loss of time and health and reputation, but it helps us up-level our operations practice. And so post-incident reviews are really, really important. They're important for the operations folks. They're important for the developers to be involved in, because this is where we get actual value and signal out of our incidents. Then there's the question that you encounter also, which is the testing and release or the deployments process, right? Is it possible through the right sort of testing framework and et cetera to prevent certain kinds of failures from ever making it to production? And that's what this layer does for us. And then the last one I want to point out here is capacity and scale, because success can be a real threat to your reliability, just like anything else can, because your customers cannot tell the difference between your website is down because of a bug in the code that you write, or because you did not provision enough resources for it to handle the load that is coming at it. And that's kind of really important to understand. And then the other two things that Mikey talks about that I'm not going to get into right now are sort of the development process and the UX side of it. I think he's trying to make the note that people often start to build stuff with like, what color should the buttons be? Should they be blue? Blue is a nice color. And they spend time on that, and they don't spend on how am I going to monitor this to know whether it's working? Okay, so the thing I want to point out here that's really kind of important to know is this is not all that SRE is. And everything I'm talking about it's not all that SRE does. But if you are just starting into this journey and you want to know where to start, it's an awfully good place to start. So there are three things that I usually talk about when I talk about practices for SRE: SLIs and SLOs, and I'll explain those acronyms in a moment, operational balance, and learning from failure. And all three of them have one thing in common, which is this acknowledgement that the right feedback loops improve reliability in your organization. And an SRE team or an SRE person or somebody who's trying to use the SRE philosophy or bringing in SRE tools is, in fact, trying to set up the right feedback loops and nurture them. And that's one of the things they can do. So one of the examples for that is service level indicators and service level objectives, SLIs and SLOs. And we'll talk very briefly at a very sort of high level about these, just so you have a sense of what this is. Now, in order to do that, however, I have to kind of expand your idea of what reliability is, because most people, when they think about reliability, they think about availability. Is my thing up and is it down? And yes, you're going to probably spend most of your time paying attention to this, but that's not all that reliability is when we're talking about what the expectations are for your systems and services and products. There's also latency, right? You've heard the term slow is the new down, right? You have to pay attention to latency. You also probably have to pay attention if you're running pipelines to throughput. Or if I'm running batch systems, I might care about coverage. Am I processing all of the data? Or maybe, and many people don't monitor this at all, are the systems that I've set up doing what I expected to as a developer? Am I getting the correct results that I expect? Fidelity is the question. If I'm running a complex, let's say a website, let's say I'm running the website for Netflix, right? Netflix has got a complex website, and everything that you see there is provided by a bunch of microservices. So if there's a problem with one of those microservices, let's say their recommendation engine goes down, you don't go to Netflix and there's a big white screen that says, sorry, can't stream today. Instead, what you see is a website that has a big chunk taken out of it that's been replaced by a static piece of HTML that gives you a degraded experience. And fidelity is like, how often am I serving the full experience and how often am I serving a degraded experience? Then there might be questions of freshness if I'm running a system that handles election results or sports scores or medical records. And then finally, durability. If I'm doing something around storage, I might care about that. Okay, so let's talk, if we might, about one crucial thing that I have to say. All these things go into reliability, but here is one of the things I'm hoping you're going to take from my talk, which is that reliability is measured from the customer's perspective, not the component perspective. I'm going to say that one more time because it's so important. Reliability is measured from the customer's perspective, not the component perspective. And now I'm going to do a little quiz to make sure that you get what I'm saying here. So I'm guessing that everybody who's listening to this call has suddenly become sick of their job, and they decide what they really want to do is they really want to join a company that makes tote bags with clouds on them because they think that's the next best thing. And so your responsibility in this company is to set up the infrastructure that allows us to sell these tote bags. And in order to do that, you set up 100 different servers, 100 different backend servers. Yes, this is 100 things. Yes, putting things on the slide, 100 things on a slide in PowerPoint is tedious as heck. But I'm sparing no production values for this particular talk. Okay, now imagine you have these 100 servers and then something happens in the data center somewhere. Maybe there's a power fluctuation. Maybe people have loaded the wrong code on, or there's an upgrade that goes bad. And 14 of these servers burst into flame and are not usable, whatever happens to them. Okay, so let's review the situation again. You have 86 servers that are working just fine, and 14 of them are currently not operational. Now comes your quiz, and I'd like you to vote. Please vote in the chat if you can, or out loud if you want to surprise whoever is near you. But I really want you to vote on this. Is this situation, 86 of them are up, 14 of them down, A, no big deal. I can continue to sit on the beach with my fruity drink and a coconut with a paper umbrella, and I'm going to get up when I feel like it and go deal with this because, I'm spending money for those machines. I should probably deal with it. Is the situation B, yeah, this is a problem. I should get up right now and walk to my desk and get working on this? Or is the situation C, an existential crisis, such that if this was happening at 2 a.m., I would still be calling all the C-level people and waking them up and scrambling everybody to deal with this? Okay, now it's your turn to vote. You have 5 seconds. Please vote. Okay, so now let me give you my answer to this question. I'm hoping you voted. I'd be very curious to look at the chat after this to take a look. I can't see it right now, but I'm looking forward to it. My answer to this question is written on my t-shirt, and I'm going to try to stand up in the fond hopes that you can read it. If not, I will read it to you. My t-shirt says, "It depends." Let me explain that. If no customers notice that there's an issue with your system, if nobody can tell the difference because of the way you engineer it, it might be A. You might be on the beach still, and it would be perfectly fine. If there's a degradation in service or there's a problem and you're hearing things about it, yes, you might want to walk over and fix it, so it might be B. Or if, in fact, you've engineered your system in a way such that it's down and you're just losing money every minute you're down, and it's a threat to your business, it is an existential threat, yeah, you might be scrambling everybody, including your C-level. So that's the thing to understand here. I gave you information when we went into this quiz. I gave you good, objective information. I told you 86 were up and 14 were down, but it turns out that's not the important information. That is not what matters here. Reliability is measured from the customer perspective, not the component perspective. So let's talk about how we might measure it. So one of the things we typically do in the land of SRE is use SLIs and SLOs. So let's talk about what those are. So we start off with a service level indicator. And a service level indicator is just, if you remember all these cool things we talked about when it came to reliability, what are we going to measure? What's the metric? What can we actually measure and know whether things are working? So if I were dealing with, say, like a web server, I might be interested in the number of total HTTP calls, but probably I'm really actually more interested in the number of successful HTTP calls over the number of total HTTP calls. I'm probably interested in this ratio that we have here. So that ratio I can take, and I can do this really sophisticated math and multiply it by 100, and I get a proportion. So here's an example of that math. 0.5 times 100 means I've got 50% availability. Cool, right? That's a number. This is what I can measure for sure to tell whether things are in fact what I want. I'm getting this percentage, and that's what I'm shooting for. But here's the deal: reliability is all these things, and what I just told you is really cool, except what I just told you is not as clear as it needs to be. Why is it not clear as it needs to be? Because if I am having a conversation with, and here, let me take off the fuzz out here because this typically freaks people out when the slide is blurry. If I'm having a conversation with a colleague and we are talking about some reliability numbers that we care about, it is really crucial for us to say to each other where these things are being measured from. Right? Because let's say that I am talking to you and I'm telling you about the problems that I'm seeing at the load balancer, and you're talking to me about what you're seeing from the server's perspective. It may be the case that the packets never got from the load balancer to the server. And so everything looks great on your side and it looks terrible on mine. And we're having conversations about two different sets of data. So it's really crucial that we add where we're measuring it from. And so it's easy to say that. You can say as measured at the load balancer or at the server. If I'm talking about latency, I might say as measured at the client. Super easy to do. Now, the tricky question you might then ask is like, well, how do I know which one to get the right feedback loop? And the answer is, it depends. The one piece of advice that I give is know your trade-offs, know the difference between what you're actually going to be measuring, where you're measuring it. And it is often, as another piece of advice, good to measure as close to the customer's experience as possible. Cool. So now we've figured out what we're going to measure, but that doesn't tell us anything, right? Now we need to think about the objectives, because if I say to you, hey, the database layer is running 80% of capacity, is that good or is that bad? It could be good. It could mean that we're using our resources, really well, or it could be really bad. It could mean that like things are really slow for the customer, and this is something we need to deal with. And so that's where the service level objectives part comes in. That's the question where we're saying, okay, we get these things of reliability. What is our expectations over a week or over a month's time for these things? And that we can say that in a pretty easily recipe. Like if I were to make a cake, it would just have 3 elements in it. It would have the thing that we're measuring, HTTP requests, storage checks, operations. It would have the desired proportion. This is where we put our objective into play. Successful 50% of the time, can read 99.9% of the time, will return in 10 milliseconds, 90% of the time. And then to make sure that we're having the right conversation about objective data, it's also important to indicate the time horizon. Over what time period are we paying attention here? In the last 10 minutes, during the last financial quarter, often we use a window, like in the last previous rolling 30 days, so we can measure the same number of samples every time. And there we have an SLO. So we can have something that says, here's an example SLO. 90% of HTTP requests, as reported by the load balancer, succeeded in the last 30-day window. And that sounds like a conversation you could have with a colleague, and we'd be talking about the same thing, and we could have a productive conversation. So what do you do with this stuff? Oh, I'm sorry, let me just give you the latency version of it. Like that, you could be 90% of HTTP requests reported by the client returned in less than 20 milliseconds in the last 30-day window. But what do you do with this stuff? Well, there's lots of stuff you can do with this. I usually tell people to just start working with this stuff, because it means that you're going to start to have conversations in your environment that you weren't having before amongst the right stakeholders, you, the developers, talking to the operations folks, talking to the business stakeholders, et cetera. I usually say start there. But there's lots of stuff you can do with this stuff. It can be a work planning tool. And let me explain that as well. So I might take my SLI and SLO, I might put it in my monitoring system, which we already talked about being necessary to be the one single source of truth that people believe in. And I put it in my monitoring system, and let's say it's time to do a new release of the software. I the developer, has created a new release, and I'm going to go put the new release out there. Well, let's say that I have this goal for the service that I'm writing, that it's up 80% of the time. And I go look at our monitoring system, and it says, oh, yeah, in the time period that I expected, it's met the objectives. It's been up 90% of the time. Cool. Good to go on the release. Totally fine. Sounds great. But if I look at the monitoring system, and that particular service has been experiencing enough downtime that it's been up 60% of the time, I'm using just round numbers because it's easy to talk about, I might choose to gate that release. I might choose to go back and put instrumentation in to try to decide, to help me understand why it's been having this issue. I might spend more time debugging things. I might redirect that effort towards releasing a new thing, towards figuring out what's going on and improving the reliability so it meets my objectives. Because again, the idea here is to make sure that we have the right feedback loops. Two other things that I think are good practices to know about in the land of SRE: operational balance. So one kind of operational balance is the balance between reactive work. Am I spending all my time dealing with crises, responding to tickets, or doing stuff like that? And you know this from your own experience as developers. Or am I spending time in project work? Am I actually improving the service? Am I improving the reliability of the service? And you can't really do one when you're trying to do the other. The other kind of thing that comes up in the land of SRE that people talk about a lot is toil versus everything else. And I want to talk about toil just for 1 second, because we have a very specific definition when we're talking about toil in SRE. Not that dissimilar from everybody else's definition, but I want to say it because it's useful to get it out there. So toil in SRE land is got a couple of properties. One, it's the stuff we do that's mostly manual labor. It's often and definitely happens all this time where I have to do it over and over again. It's repetitive. Ideally, it's automatable, but hasn't been automated, and it should be able to automate it. It's tactical. It's just reactive. There's no strategic value that I put time in when I'm putting toil towards a service. And then finally, and perhaps the most crucial thing is the work that I do as part of toil has no enduring value. It's just part of the operation of the system. But let's say it's like every Sunday, every Monday, I have to spend 2 hours running the right things to create a report. Well, at the end of this, the system isn't any more reliable and doesn't have any more features, and there's nothing more about it after I run the report. It's just something I spent 2 hours on. And if there's something I can do about that, I should. The other thing that we often find about toil is that it scales linearly. So if you have to do something, it takes you an hour to do 100 things, it's going to take you the commensurate amount of time to do 1,000 things linearly, that linear scaling. And that's not good. You don't want that. Okay. Last one of the processes that I want to talk about is learning from failure. And for that, you'll be pleased to hear that we're going to bring back in this picture. So back at the beginning, I asked if you were satisfied with the explanation of pilot error. And so I want to say that this man was not. This is Alphonse Chapanez, and he was a military psychologist that they brought in to try to figure out what was going on. And he spent a lot of time, even though he had seen the diagnosis of pilot error, actually interviewing the pilots to figure out what was going on. And after a while, it became abundantly clear what was going on in this situation. And it wasn't electrical or mechanical failure. What he discovered, and here I'll just show you a picture from the original manual for the B-12, is he noticed that there were two switches next to each other, the flap switch and the landing gear switch. They were right next to each other. They looked almost exactly the same. And here's a recreation that somebody made from this time. You can see the original ones. They're right next to each other. They look exactly the same. They operated exactly the same. And what he discovered is that people would come in, a plane would land, and they would, the pilot would go to do what you have to do, which is, lower the flaps and then, raise them back up again, and then make sure the landing gear was in the right position, and would do the wrong thing. And so what he did to fix this is he said, okay, I'm going to try to differentiate these. So he took a piece of a rubber wheel and glued it on the landing gear. They put a flap-like thing on the other switch. And just to give you some idea what that looks like, here's it from an Airbus 320. Because what wound up happening once he did this to differentiate these two things, the accidents immediately stopped. And in case you're curious, it is now the requirement in the US that your landing gear looks like this, and that your flaps look like that, and that they're distinguished from each other along these lines. And I tell you this because this is an example where if we had just said it's pilot error, if we had just not examined the failure carefully, we would not have gotten to this important place. And so what's the big idea here? After every significant incident, we're going to perform a post-incident review. And the key thing to understand about this post-incident review is it has to be blameless. You can't spend the time looking for whose failure it was and then just fire them. Because here's the thing. You can't fire your way to reliability. If you fire somebody every time there's an incident, you're going to have a team of 0. And that is not a reliable team at all that can help you with anything. At the best, you might have somebody in the data center, like with a cigarette, looking really nervous, afraid to change anything. So it's really important to make sure that your things are blameless, because what we're trying to do here is have an honest inquiry with discussion, discourse, dissent, and some discovery associated with it. Because a post-incident review is not a document or a report. You might produce one, but it's not that. It's this learning experience. It's not meant to be a determination of causality, because we know that incidents are not that simple. It is never the case that we're just trying to figure out, oh, I see, it was Colonel Mustard in the kitchen with a candlestick that caused that service to go down. There's a lot more to it. There's a lot more we can learn besides just trying to say, this is the root cause, here's the causality here. And then finally, it's not a list of action items, though you might get some there. It's meant to be just straight up a learning review. You're trying to learn from it. Okay, so let's actually move towards the end of what I wanted to say to you and get to the questions. To do that, I just want to leave you with the answer to the question of how does an individual start? So what I usually tell people is that they usually have an experience, like a problem or some downtime, and they get into this SRE thing. Some people jump up from their bathtub and go eureka and say, I must pay attention to reliability, but that doesn't happen very often. First thing you want to do is get management support lined up, because you have to make sure that everybody agrees that reliability is important enough to put this attention and these resources to it. Then I usually tell people to take and read these books. The first two from O'Reilly. The first two books were produced by Google to describe their experience running SRE in their environment, and a little bit outside Google, but mostly in Google, and why they did things. And they're phenomenal books, and I really suggest you read it. Full disclosure, I wrote the one on the end, which was meant to sort of address what happens. It addresses a number of things, but one of the things it addresses what happens when you take the SRE seed and you plant it in different soil outside of Google. And that was one of the things I wanted to address. But the thing I want to say about this is you have to read the books critically. You can't just like have Bible study where you're sitting around reading chapters of the SRE book to each other and not trying to figure out which of the things matter or which of the things might be useful for your environment. It's really crucial to read them critically. And then spend some time with other SREs. One way to do that is to pay attention to or attend, now they're virtual, but they'll hopefully go back to not being virtual, to SREcon, a conference for SREs. And again, full disclosure, I helped found this conference because I wanted to make sure that people in the SRE field could talk to each other. And the good news is that if you go on the Usenix website for SREcon, you can see all the past content from all the past SREs that we've ever had. And you can watch tremendous amounts of great stuff. All the videos and the talks are available. So go do that. And though I was making fun of a Bible study, if you wanted to watch a video with your teammates and then talk about it afterwards, that would be a really good use of your time. And then the other thing I tell people to do is try out this SLI and SLO stuff. It will allow you to start having these conversations in your environment about reliability that can really be transformative. That's been my experience. Okay, and with that, what I want to do is come back to our fine friends, the hosts, and answer some questions for you folks.
Thanks, David. Amazing. And we actually have one question here from Alejandro. And he's asking, how would an SRE introduce SRE practices into the company that has been in business for years and has gained a considerable amount of technical depth? So I guess you can read it in your book, but can you share a bit about it here as well?
Yeah, absolutely. And I'm not saying that everybody should go rush out and buy my book. They might want to wait for the movie version. That would be what I'd recommend. But the direct answer to your question, Alejandro, it's a really good one. To my mind, it doesn't really matter how long your company has been in business or kind of how much technical debt you have. The only deal with technical debt is it becomes a little harder to figure out where should you spend your time. So let's just ignore that and assume you do have the time on this. What I really suggest is what I said here, which is start off by pick a service, and it doesn't matter whether the service is your mainframe or anything else. It could be as old as the hills or whatever, but spend some time coming up with SLI's service level indicators. What am I going to measure about it? And some service level objectives, and get the right people in the room to have these conversations about this service. That's just a start. It brings in a practice, and it puts the attention in the right place. It starts using the right language, and you're going to find that, okay, maybe this is going to change a little bit about how we do things. So I don't suggest, just as an anti-pattern, you do title flipping. There is no value including less ink on business cards to just say, congratulations, team, you are now SREs, right? That you can't do that without changing the focus of what people do. So I guess that's the important thing to understand is that just sort of dip your toe in this sort of stuff. It's not an all or nothing thing. It isn't tomorrow everybody switches and now we're being SRE. And if that's what's going on, I highly doubt you're actually doing the stuff that would be directly impactful from an SRE perspective. So just start with the SLI, SLO stuff. Read the books. Get people talking. If there's an itch inside the company, find the people that think the way you do, that think about these sort of things, and gather with them and see if you can try to just do this. Because with SLIs and SLOs, if you just create them and just pay attention to them a little bit, you're going to find some value. And then people are going to be like, oh, look at that team over there, seems to have their act together about their service. How do we do that? And then it grows from there. So that would be my direct answer to that question. Hope that helps you, Alejandro. Get started. Get started is what I want to say.
Yeah, that's really good. So I also have a question just for myself. Sure. So I also work with a lot of customers building services in cloud, and a hot topic at the moment, as you also know, and what we have worked together on before is cost, right? So yeah. Do you often get this question? I mean, if we are to build this for site reliability and all the bubbles that you talked about in the reliability chart that you have, it's gonna have a price, right? So how do you find the balance?
Okay, so I'm assuming you're talking sort of staffing cost, right? I mean, because we can talk about the role that reliability has towards cost, because it turns out to be a slightly, it's a complex relationship, and I'll say that much. Let's get that out of the way for a moment, then we can come to the slightly easier part about staffing. It's a complex relationship because on one hand you think, oh, well, if I want to make things more reliable, more fault tolerant, I need 2 of them. That's going to cost more money. But on the other hand, you think, well, like if I go down and I'm not making any money, well, that costs a lot of money. So it's definitely worthwhile to spend this money, this sort of things. Or if I put a caching layer in place, that's going to cost more money, but ultimately things are going to go faster. More customers are going to be able to use the system. And so I'm going to get something from that work. So it's a complex relationship that goes back and forth where reliability both costs more and costs less to the business. And so that's where I would start to go around the staffing stuff, is to just understand that it's a matter of where you're putting your attention. Like people don't often think like, oh, security, that kind of costs something. Maybe we shouldn't have people who know anything about security around because they cost more, right? It's kind of part of the doing business. And if you my experience is either you put the money towards it or it comes and finds you and demands it from you in terms of unpaid labor, unexpected outages, and et cetera. So I think it's far better to be intentional than to have somebody else put a gun to your head and say, quick, get working on reliability.
Yeah, it's a really good point. It's just about to find what are you comparing together, right? Because some are just comparing the cloud cost. So we have this architecture pattern and our cloud bill is going to go up, right? But you also need to compare it to the other and not doing it.
And I just want to say that what I'm talking about here, SRE does not, though it grew up from a cloud company, came out of Google back in around 2003, if I remember correctly. Though it came from a cloud company per se, there's nothing that says you can't do SRE on-prem, or you can't be doing these sort of things on-prem. I mean, if you're writing stuff on-prem, it's a service. It has things you can measure, things you have an objective for. Like there's that as well. So I don't tie it directly to a cloud thing. The ability with the cloud thing is it means that you have the ability to change things in a more fluid way often. You have the way that you can deploy things. Somebody else can run some part of this of the infrastructure for you, so you can focus on your development work. There's lots of stuff that you get out of it, but there's nothing endemic to the cloud that says, if I'm not in the cloud or 100% in the cloud or have always been in the cloud since I was born, I can't do SRE. One of the things that I think that I still hear now, and I heard it in a customer call yesterday, is like, how do people who are not tech unicorns do SRE? And I'm like, you should know that everybody in my experience does it, and it has nothing to do with where your company is based or whether you have a single horn in the middle of your head, in my experience.
Really good point. Really good point, Tim.
Very good point. Yes. And by the way, I just put it in the chat, since it's our 30th 30th episode anniversary. So we are handing out a lot of swags, and one of them, actually Alejandro won it because he had a very good to the point question. And Rasmus, sorry, I cannot give you any swag box, even though that your question was also very good. You have enough.
I thought you were going to say you were going to give away like large sums of money because it was your 30th thing. That's what a pity. There goes that idea.
But to the audience, there we still have time for one more question.
Yeah, I'd be happy to answer anything you have. And I wanted to say that if you think of your question after the show, and I know it's hard to believe there'll be an after the show because it's so great, but after the show, feel free to tweet at us, right? My handle is right there, Otterbook. It comes from the name, because I had an otter on the first book. If you really want, this is back, I was on Twitter before we understood what Twitter did. And so that's why I picked that particular handle, because it was for the book at the time. But you can reach me at Otterbook, and I'm happy to answer questions. I'm happy as part of my role at Microsoft to talk to people and to talk to customers and have questions. I just suggest you pay attention to this, because as far as I'm concerned, and we should talk about this very briefly, like developers have, as much or more responsibility for the reliability of their systems as anybody else in the company. And just like, if you hire a security person, doesn't mean it's their job. It's, to do all the security work in your company. You have that responsibility too. So there's value in understanding this and working in this framework for you as well, has been my experience. And I'd also say that one of the things that may not be immediately apparent is that it's not uncommon, and in fact, it's pretty usual for SREs to be writing code themselves, or to be able to have commit permissions to the main code repository, because you really want the SRE to say, I see you've had this downtime. Yeah, have you noticed how you're freeing memory? Like, it doesn't look like you're freeing memory, enough here, and you've got this race condition over there. It's good. You don't necessarily have to be that, that level of a coder to do SRE stuff, but it's really a good idea. And there are companies like Google that hire with the exact same requirements for coding as for SRE as they do for SWEs. They're software engineers. So I want you to understand that if you think this is really cool and you're currently a dev now, and you're like, I don't know how I can do that. Yes. Please come over to the SRE side. We need you, is what I want to say.
Yeah, thank you for mentioning that. And that was a really good point. Yeah.
Yeah, it's perfect. So, and I think on that note, let's go follow David on Twitter, and you can also ask questions in there. And if anything comes in the chat, we will also, of course, forward it to David afterwards. And
appreciate that.
And have it in the follow-up email as well. So please stay with us here in the show, David, but we'll just slightly turn into the wrap-up. And in the audience, if you have any final questions, please put them in the chat. We still have David with us a couple of minutes more.
Yes, and as I promised in the beginning, we also have Azure Heroes Learner Badge for all of you. You can just go ahead and scan this QR code to get your learner badge, and this is one of the badges that we have from the collection of Azure Heroes, which we have. I will put it here, where we have more information about it on aka.ms/azure.heroes. Please go ahead and check it out. We have multiple different type of badges that you can nominate yourself for them or one of your community friends. And of course, David, you will get a kudos badge from us as a thank you for speaking at our show, and we really hope to have you back here.
Yeah, and another QR code. We want your feedback. David wants your feedback as well. So both in terms of this session, what do you think was good? What could we improve? And is there anything that you want to ask us also in the feedback form? And then we also want to hear from you. What do you want to hear in the future? Like we had the request for the SRE topic earlier, and we got David on the show, then you can also request other topics. Then we will get other speakers on the show as well. And of course, also, if you want to speak yourself and share with the community, also put it in there, and then we will make sure that you will also be a speaker on the show.
Yes, and this is also another opportunity to get another prize here.
Oh,
so
yeah.
we also, today feel like Christmas. So, so please fill out the form. And the next one is our upcoming event is on April 13th with Eva.
Yes, we will go. Will you just share about this?
Yes.
I will shut up.
So, yes. So next week and the week after, we are on Easter holiday. So we won't have any show there, and we will get back on a weekly basis from April 13th with Eva. And of course, you can go out to our meetup page and to actually see our upcoming event. We added a couple of more there, and we really want to see you there. So
thanks everybody for joining. Thanks, David, for being here and sharing your knowledge. We really appreciate it. Yes. Have a great afternoon, everyone in our side of the world, and have a great day, David. And thanks a lot.
Bye, everyone.
Yeah. See you. Bye-bye.
Bye-bye.